Hello everyone, this is Mr. 13 Things, or Silence Did Good, coming at you once again, laying in these 30 videos of 13 things at a time to first pass through to kind of show how we go about, or how we might go about, laying things into a visual framework built on the concept of 1 hour's rotation on the planet. About the world rotates slightly more than 360 degrees in 24 hours. It actually rotates about 1/365th more, but for all intents and purposes, let's talk about 15 degrees, or pi over 12 being the angle that the Earth rotates in 1 hour. And now we extend up from some of the trigonometry into some of the key engineering concepts that one really needs to extend upon. And this is in addition, of course, to the first ones, which we will put here as distance as a vector, mass, time, temperature, current, luminosity, not to be luminosity, and moles. So these, of course, are the 7 things. Look up George Carlin if you would. We live in Wisconsin, where they took him off the stage. So the 7 standards, basically the base standards in the metric system, are of all science, but building with and on these, we come upon 13 pretty good places to start, which eventually expand out into what we call derived units, or derived concepts. So let's now put those, and I'll show you again. We're going to go with 13 things. Realistically, I really meant to do 12, but all of a sudden it became 13 because I'd forgotten the way a circle works with, basically, if you divide it up in 12 pieces, you get 13 endpoints. So that said, we'll start here with something that we're going to start with unitless on this side, and over on this side, we're going to end up with something called unit weight. So this is going to be unit weight. Right? Up here, we're going to put actually the concept of force. And over here, we're going to start with something called specific gravity. And you're going to understand why in about, hopefully that feeds. Specific gravity, you're going to understand why in a second. Specific gravity is unitless. The other thing that throws many, many people is the fact that we actually should measure angles. I'm going to put this idea of theta in radians, right? They are unitless. When you make that leap, things become a lot easier and understandable in much of science. And most especially, you understand what e to the I pi equals -1 means. So, specific gravity is unitless, angles are unitless. We then start moving our way up with distance, the same as the vector here. We have then the square of distance, which is area. We have area times depth, or area times thickness, which is volume. And you've covered, for the most part, the main 3 dimensions, if you would, of distance, though there are more and more as you get deeper and deeper in engineering. But pretty much distance, area, and volume being distance squared, and distance cubed, covers the concept of space, if you would. And then we have this concept of mass. What in fact that means is different for any, it isn't actually different, but it can be measured and described many different ways as you go up through a curriculum. Mass, very often taught originally as the amount of stuff that are there. Mass, and then force, and then the next logical thing to do is put force with distance, which is work or energy. I'll just put work here. And then once you have work over time, you have power. After that, it's maybe a little bit tough to see that this is a logical, but this is the way we construct it in this something called the circle of units. I'll put that here, the circle of units. Realistically, it's units when we apply units to these things, but let's just go with the concepts. So we are up to power. The next thing we see is one of the most interesting ones and that is pressure, where in effect it has two meanings. The next one is also really, really important, and it comes up a lot more often than you would think from the first time you're on a teeter-totter. That is the concept of torque or twist, and then finally this concept of density, which basically density is something we learn correctly or incorrectly, and for now I'm going to call it mass density. Once you have these 13 things, you can then start to draw some relationships between them, and I'll just do a couple of here. We're just trying to learn 13 things at a time, and let's once again explain how you might want to go about learning this. Again, try to lay it into the top 13, basically 1 hour divisions in a 24-hour clock. Why not do it this way? We'll see why you could do it any other way as well later, and you're leaving space down below here for perhaps maybe some other things like voltage or current that you see come up over here. So what we did is we started with things that were unitless, and we went things over here. We ended up with something that were something over volume, and you'll see later why that pressure one becomes a little odd. It could be actually, these two could be switched. But what you had was a unitless quantity, which is specific gravity, which has many definitions, but it basically compares something's density to the density of water at 4 degrees Celsius. Angles, this is the key one. Angles are unitless when you truly measure them in radians. And then we had distance, which is a vector. You're going to see generally distance can be thought of a vector. When you square a vector, you do not get a vector. Volume, so you have distance, area, volume, mass, force, which becomes mass times distance over time. And we really want to put, I guess when I say that, we really should have time down here in the center, which becomes 14 things. So you have force times distance, and a dot product is work. Work over time is power. Force over area or energy over volume, that being work over volume, is pressure. Torque, which is also a relationship of force and distance, but at a 90-degree ratio. It's the amount of twist. Density, which is mass over volume, and unit weight, which is weight over volume, or density. I'm going to put the symbol here. Symbol for density is there, and the symbol for unit weight is there. Or density times g. So this is, we also can learn that unit weight is equal to the mass density times the acceleration due to gravity, which we know very often is 32.2 feet per second squared, or more likely 9.8 meters per second squared. And so you have, again, 13 things. Specific gravity, radians or angles, then distance, area, volume, mass, force, work, power, pressure, torque, mass density, and then unit weight. 13 things, and the whole concept of adding time in here to make it 14. That said, thanks for listening. What we'll do on our way out the door here, just so we can maybe use this twice, is we're going to now change colors if we would. And I'll do that by changing to green. And we can put then the basic units are unitless. So this is no units. And this is no units. That's an important concept. In the metric system, this is meters, this is square meters, this is cubic meters, this is actually kilograms. Force is newtons. Work is joules. Power is watts. Pressure is pascals. Torque is actually newton meters. It doesn't have a special name. Density would be kilograms per cubic meter, and unit weight would be newtons per cubic meter. These are the standard units in the SI system, of course, with time being seconds. Thanks for listening.